Hey guys, Mr. Moore here. Just going to go through our notes for today. We'll continue on with our West Region notes. So if you're getting out your paper and pencils, preferably a notebook, so you're keeping everything in the same place, then we can get rolling. So we left off with the Cascade Mountains. Okay, so I'll go ahead and share this with you. All right. So last we were talking about the Cascades. Okay. Um, Cascade Mountains, as we know, are in the northwest. Okay, so we're looking at the states of Northern California all the way up into Canada. Okay, so that includes Northern California, Washington, and Oregon. Okay, we talked about the Cascades being part of the Pacific Ocean's Ring of Fire. So some of those Cascade Mountains are made of volcanoes. All right. Of all the eruptions in the contiguous United States, that means the continental US, the 48 states. Okay, in the United States over the last 200 years have been from Cascade volcanoes. Okay, the two most recent were Lassen Park from 1914 to 1921, and a major eruption of Mount St. Helens in 1980. Okay, minor eruptions of Mount St. Helens have also occurred as recently as 2004 and 2008, but definitely not on the magnitude that we saw in 1980. Okay, the Cascade Range is part of the American Cordillera. Okay, a nearly continuous chain of mountains that form the western backbone of North America, Central America, that would be Mexico, right, and South America. So if you look at the west coast of South America, Mexico, and all the way up into Alaska, okay, we have almost a continuous chain of mountains that go from south to north. Okay, so that's what we call the Cordillera. All right. That is significant to each of these regions. The mountains may be different. Some may be volcanic, some may be just natural, some may be erosion, some may be caused by wind that has blown and collected um, those sands and things in those areas. But all of them have mountains. Okay. So we'll talk a bit more about that too. All right, let's take a look at Mount St. Helens. Okay, Mount St. Helens is located in Washington State. Okay, in 1980, it erupted and spewed ash many, many miles. Okay, so we're going to take a look at this video. I think you'll find it really interesting. You may want to take some notes from it and make sure you're paying attention.
Almost 10,000 feet tall, Mount St. Helens is one of several active volcanoes in Washington's Cascades Mountain range. By 1980, it hasn't erupted for over a century. But beneath its serene exterior, Mount St. Helens is beginning to stir. On March 27th, red-hot magma from deep within the volcano rises high enough to come into contact with icy meltwater.
No matter where you are on Earth, there's beneath you somewhere, there's water. So if something hot comes up into that water, it heats it up. It can build up enough pressure that it finally just breaks through as an explosion, like a pressure cooker you're just letting loose.
Most scientists expect that if the mountain does blow, it will be in a classic vertical eruption, affecting only a limited area close to the volcano. But the mountain could explode sideways in a lethal lateral eruption, devastating a much larger area. At 8:32 a.m. on May 18th, 1980, they get their answer.
We are directly above Mount St. Helens now, and there is no question that the volcanic activity has started. Smoke.
A massive earthquake causes the huge bulge on the mountain to collapse, removing a mile-wide chunk of the north face. With an energy equivalent to 1,500 Hiroshima atom bombs, rock and superheated gas shoot from the volcano at terrifying speeds of up to 400 miles per hour. Such is the force of Mount St. Helens lateral eruption that an incredible 1,300 feet of mountain disappears almost instantly. Now the eruption enters its next phase. Expanding magma inside the volcano sends thousands of tons of scorching rock and gas high into the atmosphere. A dense plume of ash stretches 15 miles high. The choking ash fills the air outside, turning the sky dark. Breathing becomes almost impossible. In the minutes after the eruption, 46 billion gallons of icy meltwater start to pour down the mountainside, gathering rock and debris to create a lethal slurry called a lahar. The deadly lahar becomes a massive tsunami of destruction. Scientists scramble into the air to get an overview of the unfolding disaster.
I was awed by what I was seeing. We could see this tremendous eruption column and all the energy that there must be in it.
Navigation is almost impossible. The ground below now bears no resemblance to any of their maps.
There were lots of fires burning. Within the cloud, there were mixtures of ash and rocks, boulder rocks from the volcano, and a lot of steam from melting glacial ice.
Mount St. Helens continues to erupt until late in the afternoon. Ashfall forced towns and cities up to 300 miles away into a state of emergency shutdown. In just over 2 weeks, the ash circled the entire globe. Officially the deadliest, most destructive volcanic eruption in U.S. history. The eruption ultimately claimed 57 lives.
All right, guys. So I am going to share this next video with you. Okay. It's important that you guys pay attention to this because luckily, having so many scientists in the area, we were able to collect a lot of data and information from this eruption. Okay. And I'll just play this next one for you. Okay, this major geological event allowed scientists to research and discover many new things. Okay, so I'm going to start this one. This one's a little longer. Okay. This will show you a little bit about what it was like after.
And it swirled around
the
us.
eruption.
And you can see across the lake how the trees are laying every which way and how the blast.
You're not a dish. You're a man. Most name brand bars and body washes you rub.
All right.
Laying every which way and how the blast must have just kind of circled around in the space. And if you look behind us, on the ridge behind us, you see the tops of the trees that are sticking up above the ridgetop, how the blast that skipped over the ridgetop snapped them off, sheer, clean breaks across them. You can imagine the force that took. And yet, even with that much force and that much fragmented rock sweeping through here and shattering the forest, you can look around us and see the evidence of surviving plant and animal life all through the area. May 18th in this landscape is still late winter, very early spring. So at that time, there was a lot of snow in the area, a lot of ice. The lake was ice covered. And the evidence of the snow cover and its importance of survival can be seen in this specific silver fir tree right here. This silver fir was probably on the order of this tall at the time of the eruption. And so when the eruption came along and blasted off the overstory, the larger trees, these smaller trees were protected under the snowpack. After the snow melted, the more flexible ones were able to pop up free out of the ash. And these trees are beginning to produce cones now, and they'll provide a very important source of seed in the blast zone.
Other seeds, like that of the tenacious fireweed, blew in on the wind and took root in erosion gullies, teaching scientists yet another lesson.
Normally, people think of erosion as a negative process. They think of erosion as something, oh no, we got to stop erosion, seed it, stabilize it. But here, we were dealing with a deposit that was on the order of a few inches to a foot thick. And so we were looking at a relatively thin cap on the surviving material. So it was just a matter of erosion coming along, washing that off, and the surviving plants sprouting through. So erosion was really the foundation of the recovery. So what normally would be a negative thing was a very positive one.
Another positive discovery was that some animals had also survived the eruption.
The same thing that was true for roots, plant roots that survived below the ground, was true for animals. The animals that were underground at the time of the eruption were able to survive. Things like the pocket gopher, which lives its life completely underground, came up through the ash deposit. They were able to feed on the roots of the surviving plants.
The gophers were joined by a wide array of other creatures which had their heads down during the eruption. It didn't take long for mobile animals like birds and elk to be seen in the blast zone either. Initially, they only passed through, but now they stay year-round.
As the forest has come back and as shrubby vegetation, shrubs and small trees begin to come in, the habitat is changing. So there's more of a place for animals to nest and feed. And so you can kind of see a real picking up in the pace of regeneration. As animals spend more time in the area, they drop the seeds of their favorite food in their droppings. And so in effect, they're planting more and more of their foods. So the whole pace of the regeneration and the animal habitat is increasing over time.
Grazing animals are also spending more time inside the National Volcanic Monument due to the success of the planting operations around it. Each year, as the trees get bigger and the forest denser, the food supply there decreases.
That big open blast zone is quite a boon in terms of available forage. So we see lots of elk and deer in the monument. We also see things like coyotes and even signs of cougar. That we've even found some interesting sightings of things even like mountain goats back on the high country. So as the food base has returned and as the habitat has returned, the animals are returning in great numbers.
The waterways around St. Helens tell another story of amazing recovery. During the 1980 eruption, entire watersheds were physically altered and became hostile to traditional marine life.
I took a temperature on the College River down near the mouth, and it was 95 degrees a day after the eruption. The Tootle was literally just steaming in place. It was just a quagmire of mud and water. And my initial impression was that we'd lost everything.
Though the conditions were far from ideal, nature showed surprising resilience. In side streams, some fish did manage to survive.
We were able to go into some of those tributaries and found all sorts of little juvenile trout, steelhead, and salmon. And these are the fish that are going to be the seed source for continuing the run. So even though everything in the main stem was fried with the temperatures and the sediment that we got, we had a source of recovery there in the tributary stream.
All right, guys. So that's kind of how nature recovers after an event like this. Huge volcano. Ash went for miles and miles. Some areas of the world even saw ash as far away as the East Coast. Okay, so we're talking about lots and lots of ash and lots of carbon that was emitted into the atmosphere. So, how do animals survive that? Well, some live underground, some live off of roots of plants. Okay, luckily it was in the wintertime and it didn't impact everything as significantly as they thought it would. So life has kind of come back to that region in a fairly quick amount of time. They did some manual work to plant trees and kind of get the regrowth going in those areas, which is pretty evident today. If you saw an aerial um, photograph of the area, you could probably see some tree lines where you could see where they physically planted some trees. But it's really interesting stuff. So lots and lots of research still happening at Mount St. Helens. Lots that went on during the 1980s. And this has kind of been the root of some of our arguments that have come in science over a period of time. Okay, so let me go ahead and go back to this. Okay, carbon dating is a huge one. Okay, carbon dating and refuting its methods has been a debatable scientific discussion after researching the environment after this eruption. Okay, radiometric and carbon dating helps scientists to date minerals and artifacts based on the carbon atoms contained in the object. Okay, so carbon dating is basically where we look at the mineral makeup of an item. So we're looking at the carbon specifically. We have carbon atoms of carbon 12 and carbon 14. Okay, when a living object dies, person, animal, plant, whatever, we have certain amount of carbon that we intake when we're alive. Okay, and we stop taking in carbon at that point when we die. Okay, so as a plant dies, it quits making carbon, it quits taking in carbon, and it decomposes, which then releases carbon back into the environment. Say a piece of wood is covered in ash now by the volcano. Okay, if we dig up that piece of wood, it's probably been petrified at this point, and we can take it up and look at the carbon atoms in it. Okay, so that's how they date something. The problem is with this huge eruption, the specific amount of heat that was generated, the lava flow, all these different things. Okay, they found that large areas of this eruption were dating way differently than what they were expecting to see. Okay, so it made things debatable. The best example I can give you is a diamond is formed from natural carbon, okay, pure carbon. And that pressure that builds on that carbon eventually will turn that carbon into a diamond, okay? Well, we know now that we can actually take and make diamonds in the lab using carbon as well, okay? There are some differences, but essentially it's still made of carbon, right? So this is kind of something that they saw happening in this environment, and it raised a lot of questions as to how scientists actually conduct radiometric or carbon dating. Okay, radiometric really just looks at the radioactive materials in carbon-based life forms. Okay, so there is a lot that has come from this. It's still debated heavily. Okay, some people have tried to wrap their heads around this, and it's a very sciency kind of perspective, right? But it's good because in any science, whether it be social studies, science, chemistry, biology, we have to look at and question things. And volcanoes make a very good example out of what our planet is actually doing. So we talk about carbon emissions. You guys have heard of greenhouse gases and things. Um, and one of the biggest sources of any kind of greenhouse emission is usually a volcanic eruption. So it's interesting that we look at carbon emissions from factories and things like that. When if a volcano erupts, it's going to put millions of times more carbon into the atmosphere. So how do we measure that? Well, it really depends on what you're looking at and studying. So it is interesting. There's a lot to talk about when you guys get into high school and things. Hopefully, you'll use volcanoes as a good source of information for debating these kinds of topics because there's a lot of information out there. Okay. So I'll let you guys stay with that. Just a good thing to keep in mind. Okay. Um, carbon dating, as I said, is carbon 12 and carbon 14. Okay. At the moment of death of a live organism, okay, carbon 12 and 14 is not the same as every other living thing, but the carbon 14 decays and is not replaced. Okay, the carbon 14 decays with its half life of 5,700 years. That's a long time, right? while the amount of carbon-12 remains constant in the sample. So this is where they were being thrown off, okay? They were seeing things at their half-life already when they shouldn't have been, okay? A living tree that was already there shouldn't have been at its half-life already. So very interesting, good stuff to check into if you're into that kind of science. All right, now we look at the Rocky Mountains, okay? So we're more familiar with the Rockies, but keep in mind, guys, the Rockies span from New Mexico all the way up into Canada. Okay, so we might look at the Rockies, and if you have been in the Rockies in Colorado much, you see that there are lots of different types of rock formations, lots of different types of minerals that make up the Rocky Mountains. Obviously, different places have gold, some have silver, different deposits. We have redstone, granite, we have formica, all these different types of geological formations that make up the Rocky Mountains. So it's a very diverse landscape when it comes to mountains. Very interesting to look at. Okay, the Rocky Mountains stretch 3,000 miles in a straight line distance from the northern part of British Columbia in Canada to New Mexico in the southwest United States. Located within the North American Cordillera, the Rockies are distinct from the Cascade Range and the Sierra Nevada. Okay, so the Sierra Nevada run west in California, okay, and Nevada, and then the Cascades are obviously from Northern California through Canada, while the Rockies run a little farther east. Okay. Of the 100 highest mountain peaks in the Rocky Mountains, 78, including the 30 highest, are located in Colorado, 10 in Wyoming, and 6 in New Mexico. 3 in Montana, and one of those is in Utah. Okay, so of the 100 highest peaks, Colorado has a ton of the highest peaks, and we're pretty well known for that. A lot of people call them the 14ers, so people like to try to climb as many of those as they can. We have Mount Blanca, that is near Alamosa and near the Great Sand Dunes. That is one that you can climb fairly close to here. We have quite a few significant mountains. As I said the other day, we have one active volcano in Colorado. So hopefully you guys took a look at that. All right. All right. And then let's talk a little early history of the West. Okay. With westward expansion, people came to the West in search of fortunes and opportunity. Many farmed the land in the Great Plains, others searched for gold in the hills and mountains of the Rockies and Sierra Nevada mountains. Okay, and they also explored the region from north to south and east to west. Native Americans knew the area well and used its natural resources in every aspect of their life. In the West, you'll see evidence, and still today, many cultures of Native American groups. Okay, and they're still active in those areas. Okay, trappers and traders established towns and cities. If you guys are familiar with Bent's Fort, you'll see how towns kind of began to pop up based on trade. Okay, and then eventually with the gold and silver rushes, cities became more prevalent. All right. And then after acquiring the land through the Louisiana Purchase, the Mexican American War, and the Oregon Treaty, the US began to expand quickly. All right. So that's going to do it for today. Hopefully, you guys get some good notes if you need to go back, stop, pause, do anything like that. Make sure that you're writing some good notes down. I didn't highlight a whole lot of this in yellow for you guys. Just because I want you guys to start forming your own notes, start finding keywords. Okay, so you've got to be a thorough examiner of your readings and make sure that you guys are writing down the things that you think are important. Okay, so I will cut you guys loose. I hope you have a great day, and we'll be picking up on this. We'll talk a little bit about Alaska and Hawaii. Okay, and make sure you're practicing your Quizlets so that you're prepared for our test. I will talk to you guys soon. Have a great day. Bye.